So torque is a quantity that measures the ability of a force to rotate an object around some axis, and um, and it's how how easily an object rotates on both how much the force is applied and where the force is applied, right? So it's force times the lever arm times sine theta. If you have a greater force, you'll have a greater amount of torque, which can cause a greater acceleration as we rotate something. Or if we have a greater lever arm, right? If we have a wrench, if we have a long lever arm, it could be you can get more torque that way. The conventional sign of torque, right, is counterclockwise is positive and clockwise is negative. Although that's up to our discretion how we want to use that, and sometimes it's more advantageous to use the other direction. But for the statics problems, it's pretty much always that way. So let's get started with this one here. We have a force of 25 newtons on this lever arm. The angle theta inside here, right here, is 55 degrees. The arm length is 1.4 meters, and the hinge is right here. Go ahead and calculate the torque. Now you got to be careful to make sure that the trig works out, because if the trig doesn't work out, this won't work. So yeah, go ahead and pause the clip and do this, and when you're ready to check, you can hit play to continue. All right, so the trig does work out. Sine of 55, this is the opposite side, and therefore, because it's the opposite side, the hypotenuse is force. So sine of 55 times the hypotenuse, which is the force, will verify this is the angle that we want. And so we can multiply sine of 55 times 2.5, or 25 newtons times 1.4 meters, and we get a negative 28.7 newton meters. That's because it is a clockwise torque, and we get that there. All right, so for this one here, we have a seesaw. All right, so let's set up the 60 kilogram person on the left, the 45 kilogram person on the right, and we want to find out what the net torque is. What is the net torque? And so, yeah, we have the axis of rotation here in the middle, and we want to find that. So if we think about that, this being the axis of rotation, we have the force of gravity of this person, we have the force of gravity of this person, and we can get the sum of the torques, and that's what we want here. Now, it's not going to equal 0. We are going to get a net torque here because it's unbalanced. So what kind of torque is the 60 kilogram person going to cause? Well, it's going to be counterclockwise. So we have positive torque from the 60 kilogram person plus, how about the 45 kilogram person? That's going to be clockwise, which is negative. So negative torque from the 45. And yeah, we can go ahead and calculate that. So go ahead and pause the clip and do that. And when you're ready to check, you can hit play to continue. All right, so for the 60 kilogram person, with a force of gravity is mass times 9.8, which you have 588. And then we have on the right-hand side, 45 kilograms times 9.8, 441. And we have the lever arm, which is 2.5 meters. And so with the 60 kilogram person, we're going to have a counterclockwise torque of positive 1470. For the 45 kilogram person, negative 1,102.5. So we add them up and we get a net torque of 367.5 newtons per meter.